In this problem, we're going to look at taking the limit of a quotient. We want to find the limit as x approaches negative 1 of x squared minus 4x minus 5, all divided by x cubed plus 1. We look at this quotient as a ratio of two functions. We have one function in the numerator, x squared minus 4x minus 5, another function in the denominator, x cubed plus 1. We notice if we take the limit as x approaches negative 1 of the denominator, we'll get 0 in our denominator. So we cannot apply our quotient rule directly. However, we notice that both the numerator and denominator are polynomials. So we'll go ahead and try factoring first. And we'll have the limit as x approaches negative 1. In the numerator, we can factor it as x minus 5 times x plus 1. The denominator is the sum of two cubes. We can factor that as x plus 1 times x squared minus x plus 1. And we notice that we have a common factor, x plus 1, in the numerator and denominator. If we put in x equal to negative 1, we will get 0 for the value of that factor. But since we're not concerned with what happens at negative 1, just near that, we can go ahead and cancel those factors and get the limit as x approaches negative 1 of x minus 5 over x squared minus x plus 1. Now, using our quotient rule, we can rewrite this as the quotient of the limits. As the limit as x approaches negative 1 of x minus 5 divided by the limit as x approaches negative 1 of x squared minus x plus 1. Now, in both situations, we have polynomials, so we can plug in our value for c directly and get that our limit is equal to negative 1 minus 5 divided by negative 1 squared minus negative 1 plus 1. We'll get negative 6 in the numerator. We'll have 1 plus 1 is 2, plus another 1 gives us 3 in the denominator, and negative 6 divided by 3 is negative 2. So the limit as x approaches negative 1 of x squared minus 4x minus 5, all divided by x cubed plus 1, is equal to negative 2.